I'm going to tell you about one very concrete method for debugging that that I found to be really effective, and that actually it kind of prevents bugs from popping up before they even arise. So it sounds magical, but it's actually really, really simple. So part two is what's called assertions. So an assertion is a software construct that's available in pretty much every programming language, and it's probably one of the most important software constructs that that you'll learn. So some of you probably have seen this in classes, some of you haven't. So I want to introduce it. So this stuff seems blindly obvious, but it's worth repeating. So a software bug arises because your assumptions were wrong. All right, so you got to really repeat that from the first part. It's because you had some assumptions about your software and they were wrong. Because why would you put in a bug on purpose unless you're like really masochistic or you want to screw over your teammates, right? If your assumptions are right and you code it the way that you assumed and all of it's right, there shouldn't be a bug. It should work exactly the way you expect and other people expect. So that means that because, by some logic, that means that if there's a bug arising, that means your assumptions are wrong. Of course, there's another possibility that it's a bug in the web browser or the compiler, the interpreter, the operating system, the server, the hardware, the power supply, the whole universe. Yes, there is a possibility of that, but the prior on that is pretty low, right? So it's pretty safe to say, no, it's not a bug in all these other things. It's your code, and it's BS free. That it's some assumption that you're making that's wrong. So if you accept that first premise, which I hope you do by this point, then the logical next step is to write down all of your assumptions. Right? That's the logical next step. Write down all of your assumptions about your code, about what your software is supposed to do, what you think it does, what you want it to do. Just write them all down. Okay? Sounds easy, maybe or not. So how should you write down these assumptions? So some people say documentation is good. Let's write down some documentation. Like, I want to assume that, when I get a list of numbers from this other person's code or from the server, this list always has positive integers in it. Because if it doesn't have positive integers, like, my code will blow up. So I better hope to have all positive integers. You write that as like a / or whatever comment. Or you write that down in your project report, like as a piece of documentation. Oh, here's all my assumptions. Obsolete comments are probably a really, really bad source of bugs, because you think that the comment says one thing, but you read the code below it and it says something completely different. It's because someone updated the code and didn't update comments. So that's absolutely right. The big problem with comments or documentation so comments are in the code itself, so it's not bad because it's right there, so you hope to be able to update it. But what if you write like a Java doc somewhere else, or you write a design document, or you write a project report? Those have no hope of being updated, right? You're hacking on your code. You're going to forget to update all these other things. So when someone reads your design doc or your technical spec written in Microsoft Word, it's probably not up to date because you can't just keep them both updated. So problem with documentation, documenting your assumptions, is that they're not executable. You can't run them, so that there's nothing preventing from going out of date. There's also nothing preventing from being wrong too, right? If you document your assumptions in English, no compiler is going to check that your assumption was right in English. So the only thing to do is to write down all of your assumptions as executable code. So these 3 steps seem pretty obvious in retrospect, but I promise you that by applying these principles, your code will be significantly better and your debugging will be significantly easier. So remember, software bug arises because assumptions are wrong. So what do? Write down all of your assumptions. How? In English? No, you write your assumptions as code. And why do you want to write them as code? Because the code executes. So whenever you run your program, your code is checking your assumptions. And as soon as one assumption gets violated, the moment it gets violated, you know right away. So if you might have run into these cases where the bug itself arises much later than when you coded, right? So you were probably coding late at night and making some part, and it was all cool, you kind of tested it. Then 5 days later, you're working on an unrelated part of the code, something blows up, and then you look at that part of the code you just edited, and there's no bug, it's all good, and you try to trace it back, and you found that the bug happened in code you edited 5 days ago, right? So that's terrible, because when you have a bug, you never think about looking at code you edited a week ago, or a month ago, or a year ago. You think about looking at the code you find now. So if you can document all of your assumptions as code that executes, then as soon as one of your assumptions gets violated, the moment it gets violated, you find it right away and you go fix it right away. You don't wait until a week later, right? But so notice, if your assumptions are written not in code, you can't find that out. You don't know when they're violated unless you really meticulously check manually. But if you're writing it in code, as soon as the code breaks, it will actually tell you. Okay, so this sounds like it's magical, but it's actually implemented in something extremely, extremely simple. and that's called an assertion or assert statement. So what's an assertion? So an assertion, or otherwise called an assert statement, exists in all languages, or it's just trivially implemented. If it's not in your language of choice, the first thing I do when I program in a new language or a library that I don't know, the first thing I always do is write an assertion function if one doesn't exist. And here's how you write one in JavaScript. You can, I think Chrome has a built-in one, but I just wrote my own because it's like 3 lines of code. This is an assertion right there. So this is assertion code in JavaScript. It's a function. And people usually call it assert. You can call it whatever you want, but assert is a standard word. Cond is the variable. So this is some Boolean variable. And this is code does exactly what it says. If not cond, which means if this condition is false, then I pop up an alert. This is one of these annoying JavaScript alerts. You've probably seen these, right? It's one of these annoying alerts that pop up on the screen. I pop up a really annoying alert that says, oh my God, something broke. And then I throw an exception called an assertion failure. So this exception is nice because for those of you who study exception handling, this is nice. One of the real reasons this is nice is that because on your console, it'll show you a stack trace. So it'll show you what function called this and what function called that and called that. So you can actually pinpoint the exact piece of code that threw this error. So this is actually it. And in other languages, so I do a lot in Python or Java, it's called an assert statement. You just say assert and you just say some condition. That's it. It's built in the language. So the semantics for assert is extremely simple. It's probably the simplest thing it's probably the simplest code you can write beyond just like return true, right? All it says is you give it a variable, and if its value is false, then blow up. If its value is true, what happens? Nothing. Good. That's exactly what you want to happen, because if it's true, that means your assumption is good, and you want to keep executing. You don't want to break your code or print, whoa, you did well, or whatever, right? Unless you want to be really self-congratulatory, that every time you run assertion, it says, good job. But yeah, if the condition is true, that's what you expect, and you just keep going with life. But if it's false, the moment it's false, it pops up this annoying alert and throws assertion error. So this assertion is that the length of some X list is greater than 5. So yes, Matthew.
Seems like it only checks it at that time. So what if you change it after that?
Good. Great question. So it seems like whenever you put an assertion, it only checks the condition at that time. What happens if you change something afterward? It's a great question. So that actually leads to, that leads to my next point. Okay, ready? Question, what should you assert? Everything. I'll give you an example of everything. And then when should you assert things? All the time, as much as possible. All the time. So the answer to that is if you change something else, put another assertion right after it. So what should you assert? Everything. When should you assert? All the time. So your code should be 100% assertions, no actual code in the limit. It's actually not that bad. I calculate, there's a second article I put up that I wrote that for the code I write, I would say for production code that I've written, I would say about 3% to, this thing broke. I would say 3% of the code is assertions, actually. So that means every 100 lines, there's 3 assertions, I would say. So that's about more reasonable ratio, 3 to 5%, I would say. So not 99, obviously. But the idea is that everything non-trivial you should assert, and you should do it as much as you can. I'll tell you what that means in a minute. So, and then the last thing before we actually go into the code example, I'll spend most of the time today actually showing you what this means. This is all really abstract and fuzzy. I'll actually go into a really detailed code example so you see exactly what I mean by this. So then this is a non-question. Poses a question, but I know this condition is always true. It's so obvious. Why should I write a extra line of code to check it? It's like obviously true. I look at my code, it's absolutely right. I'm like, awesome. This code is true. If this condition is always true, the length of that list is always going to be greater than 5 because I put it greater than 5. Or this number is never negative because why would someone pass in a negative number? They must be a moron, right? I always pass in positive numbers this function. But what if your code changes? What if someone else uses your code in where? What if your teammate calls your code in a way you didn't expect? What if your own code, your own function changes later in the future that violates your original assumption? Because this someone else in the future is not just your you look around left and right, like your teammates, you're like, oh man, they're morons. Like they couldn't possibly code as well as me. But actually, it's probably yourself in 3 months or in 6 months. Because when you look at your own code in 6 months, you totally forgot what you wrote or what you assumed about your code. And documentation kind of helps, but that's outdated. The only thing that's not outdated is your assertions, because if your assertions don't work, your code is broken and it can't even run. So to recap, an assertion is simply a piece of code that asserts whether a condition is true. If it's false, it throws an error right away. You can use it in any language and just use it as much as possible. And the reason why you should use assertions is because of this thing that should get seared into your head, is that Bugs arise because your assumptions are wrong, so write all your assumptions down and write them as executable code. Okay, so now I'll actually show you code rather than just talking.